Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Pvt Limited. I have 14 years of work experience in the fields of artificial intelligence, software development, and robotics. This is part 5 for TensorFlow and Keras Basics. I am creating handwritten digits classification project. Let's continue. So this is how it is reading it. At epoch 1, the model training accuracy is 91.25%, validation accuracy is 94.70%, meaning the model is doing well but has room to improve. And in this one, the training 10th epoch, the training accuracy improves to 98.41% and the validation accuracy reaches 97.28%, showing that the model has learned well and making better prediction on both the training and validation set. So you can see in the first pass and in the last pass the difference in the training accuracy and validation accuracy. You can see the difference. So each epoch helps the model improve by adjusting its internal parameters based on the data, leading to better performance over time. So this is the reason it is doing multiple passes, because in the first pass you can see the performance, in the last pass you can see the performance. So when you use multiple passes, then over time things will become better and your model will become better. This is the reason you will see the epoch mentioned here. So because these are the passes, so in multiple passes, when the time goes on while training the machine learning models, things will get better, and at the last epoch your model will perform better. So as you can see, I trained the model and ran it, and you can see the accuracy. So why the accuracy? Because I am using multiple passes, multiple epochs, and this is the just a basic concept how you should also train the neural networks. You should remember this concept if you are working with neural network. These basic technology terms, you should remember these terms while working with neural networks. And if you are trying to become AI ML engineer, then neural network will be very important for you. Okay, so let's see how to read this chart. So you can see the code. So for now I will show you this chart. Okay, so let's look at the chart. So first I will run the code, of course, so that I will show you the live output. It will take some time to train and run things. Okay, so first thing, showing the digits. Now it will train the model. As you can see, it is updating the accuracy and loss functions. Okay, let's see meanwhile this chart. So these are the subplots that it is making. These are the subplots. One is accuracy over epochs and loss over epochs. So in each pass you can see the accuracy goes on, and the thing is validation accuracy in the orangish color. This is not changing much. So in simple words, as you can see, this is what is happening. And in loss over epochs you can see the elbow and this again. So this is the live output from the program that I have written here. So this is the live output. Now let's see the article and how to read this. So this image shows two plots that track the accuracy and loss of your neural network model over time. So left plot accuracy over epochs. Let's see accuracy. X-axis, this shows the number of training cycles the model has gone through. It goes from 0 to 9, meaning your model has been trained for 10 epochs. As I told you, we have given the 10 passes or 10 epochs. So these are the 10 epochs in the x-axis. Y-axis, this shows the accuracy or how often the model correctly predicts the right class. Blue line is training accuracy, so blue line training accuracy while it is training. This line shows how well the model is performing on the training data. You can see that the accuracy increases steadily over time, reaching close to 99 by final epoch. So at first there was no accuracy, but with the time accuracy increased to 99%. So this is good. Orange line validation accuracy, this line shows how well the model is performing on the unseen validation. So the data it has not seen earlier, when it is training on it, or while it is validating it, accuracy increases quickly in the first few epochs and then stabilizes around 97 to 98%. So see, it started spiking up, but eventually it is starting stabilizing the things. So validation, what you will say in technical terms is, in the starting in training accuracy, it started and went to 99%, which is good. And in validation accuracy, what is happening is it started good, but it starts the stabilization process. So it stabilizes around 97 to 98%. This is how you will say in technical terms. So what to understand with this, what you should understand with this, the training accuracy continues to improve as the model trains over more epochs. So in simple words, what you will say is, training accuracy continues to improve over the more epochs. The validation accuracy stops to change after around epoch 3. So you can see this epoch 3, so it started to stabilize the things. This is how you read it. Since the training accuracy keeps improving while validation accuracy, what this word means is, it stop making too much changes to things. So this is what this means, less changes, little changes. So reach a state of little or no change. This is what this means.
Plateau.
Okay, so it could be a sign that the model is starting to overfit. So what this means is, for new data model will not work fine, or for new data the problem of overfit is being introduced in this program. This is what it means. Okay, so let's see the right plot, how to read the right plot. This is the right plot, loss over epochs. How to read this? X-axis, again this shows the number of epochs, again the same thing, but this time on Y it has loss. So this represents how far the model's prediction are from the true labels, so how well it is performing. This is what is being shown in this chart, where a lower loss means the model is performing better. So we have to look for lower loss. So training loss is in blue color, validation loss is in orangish color. So blue, the training loss decreases steadily as the model learns. So let's see. So there was loss at first, but as the model trains it started decreasing, loss started decreasing. And then again what it means is, meaning the model is making fewer mistakes on the training data over time. So as it trains the model is making fewer mistake on the training data over time. This is what it means in this chart. This is how to read the training loss. In orange line, validation loss decreases at first. Orange line, validation loss decreases at first, but then flattens and slightly increases over epoch 3. So decreases over time, and from epoch 3 it slightly increases. This could indicate that while the model is still improving on the training set, it's starting to make slightly more errors on the validation set, again suggesting possible overfitting. So again with the new data, when the new data is introduced, so you know we have trained on the MNIST dataset. So when we try this on the in the real world scenario, reading the handwriting of the people, then it will start giving some wrong output. This is what it means in the simple words. So what are the key insights what you can look for? What it means is the training loss is decreasing consistently, which is the what you expect during training. This is what we need. Training loss should be less. So as you can see, this is elbow and we are getting less and less loss. The validation loss decreases at first but then flattens or slightly increases. So it decreases at first but it started stabilizing, which is another indication of overfitting after a certain point. So again this is the problem of overfitting. And for looking for when it goes for some to look for some new data, then it will find some problem. So what is the overall conclusion of this model? What overall means is your model is learning well as shown by the increasing training accuracy and decreasing training loss. However, the validation metric shows signs that the model stops improving after about 3 epochs. So model stops improving after 3 epochs. Further training might cause overfitting. So if you go for further training, it will cause overfitting. At this point you may want to stop training early or try equalization again and again. I am telling you this overfitting. Let's see overfitting meaning in ML. So this results in a model that performs very well on the training data but poorly on unseen on test data. So I am telling you when it sees the new data, the problem, what problem is incorrect output. This is what overfitting is. And when it occurs when the model learns the training data too well, capturing the noise and fluctuations that are not relevant to the general pattern. So it is not mainly understanding to work with the new things, it will stuck with the general patterns. So this is the problem of overfitting in ML. And of course the final thing is to evaluate the model. This is the code, and you can see if I so when I close that, then it will show this predicted value and true value. So predicted was 7 and in reality it was 7. So it is working good, model is working good. So predicted label and true label like this, and this is the test accuracy. So how you will read is let's see. So how to evaluate it? Model dot evaluate, and this is the function. So what are test images and test label? As you can read from the words and understand from the words, this is the test data where I gave it in the top of the program, if you remember, test images and test labels. So the data was distributed in training and testing data sets. So the big data set was distributed in these two parts. So there are images and labels from the test data which models has not used during training, and then comes the evaluate. This function computes the loss and accuracy of the model on the test data. So this is not now working on training data, this is the test data. This is the real world problem that we are trying to solve. So measures how far of the model's prediction are from the actual labels in the test set. So what loss is from the actual value, how much is the difference. So accuracy tells you percentage of correct prediction the model made on the test data. This is what accuracy is, and what this verbose means. This controls the level of information displayed through the evaluation. It shows just one line per epoch during evaluation. It will show only one line per epoch during the evaluation. This is what verbose 2 means. You can increase it if you want, and this will be the output, loss and accuracy, and the testing accuracy is this. So what this again means is 313 by 313. This indicates that the test set contains 313 batches. The test images were divided into 313 smaller groups or batches for processing. 0 second is the time it took to process the entire test set, was very short, less than 1 second. See, less than 1 second. So it is giving in a round of position. Loss, this means the test loss, which indicates how far off the model prediction were from the true labels on the test data. So when we see the image or handwritten digit, how far it is from the actual output that this model is giving. So the loss of this means the model performed quite well, as lower loss values are better. As I told you, lower loss values are better. And when it comes to accuracy, how you read it, 97.32%. This is how you read it, 97.32%. This is the test accuracy, meaning the model correctly predicted the test images labels. This is high accuracy, indicated that the model is performing very well on new unseen data. So model is performing on new data good. Okay, so I think I will cover the just this is just the final output that you have seen. The digit last, if you remember, I have shown you this predicted label and true label chart in the matplotlib, if you remember. So this is the code that is predicting the labels. This is the code. So this is how you plot the chart. Yes, so that's it. Nothing too complex there. So the thing was how to work with TensorFlow and Keras, and how to train a simple neural network. This was the example how you can train your own neural network using TensorFlow and Keras. This video marks the completion of handwritten digits classification project. I will see you in next session. Have a nice day.